Okay, so welcome to our next talk by Wouter, who's going to talk us about Nostr nodes and other stuff transmitted by relays. Please help me give them a warm welcome.
Thank you, everybody. Thank you for being here. I'm going to talk about Nostr. This is, I think, the first time somebody's talking about Nostr, like on a stage outside of our little Nostr bubble. We have our little Nostr events and conferences and stuff. But this time it's like for a general audience and open source developers at that. So that's pretty cool. I'm going to be standing mostly behind my laptop, unfortunately, because I'm going to be speed running through my slides. You can basically ignore the slides, just listen to my talk. I'm going to do that in order to make sure that I'm keeping like on track and on pace, so I keep time to answer a bunch of questions. So please keep your questions in mind, come up with questions, and we'll have a bit of a discussion afterwards. So because this is like Nostr outside of its own little environment, I'm going to do the obligatory show of hands thing. So please raise your hand if you've heard of Nostr before. All right, and keep your hand up if, and only if, you've used Nostr before. Okay, and you can keep your hand up if you think you understand Nostr. All right, perfect. Very quickly about me, Wouter Constant. I love StarCraft Brood War. And if you wonder on why I'm the guy that's standing here, that's hardly the reason. And for all the rest, just go with it. Okay, let's go. So this presentation, I'm mostly going to be talking about three things. Like the story has like three parts. First, I'm going to be focusing on this paradigm shift. From that, we're going to flow into Nostr. And then I'm going to try to argue why I think this is actually going to work. There was a part before this that I mostly just cut out in the interest of time that I'm shortly going to address right now, or not right now. We're just going to talk about Nostr. So Nostr nodes and other stuff transmitted by relays was invented by some guy at the end of 2019. And the opening statement pretty much sums it up. Which is, it's the simplest open protocol that is able to create a censorship-resistant global social network once and for all. It doesn't rely on trusted central servers, hence it is resilient. It is based on cryptographic keys and signatures, so it is tamper-proof. It does not rely on peer-to-peer techniques, therefore it works. All right, so briefly, I'm going to talk about platforms because it's a social media thing, right? And the reason I cut it out is because all the problems with social media and the central platform is pretty much top of mind. And I guess with just this audience, most people understand what's going on. So, but you know, why do we use these platforms in the first place? Well, apparently because hosting websites is too hard, right? We could have all just hosted our own personal website and do stuff by that way. We didn't. We all went to one particular website, named Facebook or whatever, and started to make pages there. So what do these platforms actually do? In general, they do three main things. They manage identity and networks, right? So this is your account and the people you follow and people following you. They host data, so this is your physical infrastructure of making sure that people get the pictures and videos or whatever. And the last part I call indexing. So these are like this is your search. These are your suggestion algorithms and your feed, all that type of stuff. So what is the result of the fact that we're all using these platforms is that they've captured network effect, right? That's where the value is. Everybody's there is because everybody's there. But we also incur this censorship risk, right? We're at the behest of these central platforms and they can kick us off and then we lost our identity and our network and our data, etc. All right, so let's go into this paradigm shift. And talking about this paradigm shift, I'm talking about names, right? So the core of the paradigm shift is the use of asymmetric cryptography or public-private key pairs. And the thing is about names. So there is this notion of a Zuko's triangle. It's the deal where there are three aspects. You can only pick two. It's about, you have one is human meaningful, right? So this is a name that you can understand. For instance, Bob. Bob is a very understandable name. You have this notion on the bottom left, it's decentralized. This basically means that you're able to create the name yourself instead of getting the name assigned by some central authority. And the last part at the bottom right is secure. And this means basically that the name is unique. right? That if you interact with that particular name, you're sure that you're actually interacting with like that particular person and not somebody else. So because this is a game of you can only pick two, we get like these options. So we have human, meaningful, and secure. So that's the bottom. That's the top one. It's like this official seal of approval. So this is the one and only Bob, right? There's no other Bob. This is Bob. We have human, meaningful, and decentralized. That results in, oh, there's a little quirk in a in the slide. But it results in Bob, 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 and another Bob, right? So there are Bobs everywhere. It's very human, meaningful. It's also very decentralized, but not very secure. And lastly, we have decentralized and secure. So this is based on these key pairs, and that just creates this random string. Now, if we are trying to solve central platforms, we want something that is decentralized, and we also want something that is secure. So just by sheer of like elimination, we're kind of coming out at the bottom, right? So if we want to do a naming scheme, we're going to have to do it this way. The thing is that public-private key pairs suck. They're absolutely terrible. You shouldn't use them. We're going to use them, but you shouldn't use them. And why? Because the problem is that you have this private key. This is a secret. And the thing is that you have to keep this secret super duper safe. And on the other hand, we're trying to use it in our protocol or in our system. So you also have to use it all the time. And these two things are in conflict because if you want to keep something safe, you want to like restrict access. And if you want to use it all the time, you want to optimize for accessibility. So now we want to optimize for accessibility and want to minimize accessibility. And these two things like are in conflict, obviously. So we have to manage that. And we have to manage that in a context that we're dealing with something that is not made for humans, is made for machines. So there are a lot of mitigating factors to this. In the interest of time, I'm not going to go into this now. If you have questions about it, shoot, we can talk about it. Let me take a sip of water. Now, we actually gain a bunch of this by using this system. And what we get is tamper proofing. So when we use these cryptographic keys, we sign things, and by the fact that they're signed, we can now verify that things are actually true. And as a result, we're no longer trusting middlemen. So it doesn't matter where data comes from if data is signed, because data is signed at the source and can be verified at the endpoint. So the steps that in between, or where the data comes from, who's carrying the data, they cannot tamper with the data anymore, because otherwise it becomes invalid. And this means that the data has it's carrying its own context. It becomes its own little thing. And what I mean by this, I can illustrate by this how the situation works now, which is that we're kind of stuck in place in time with the question of what is an Instagram post. So I can assure you that this is not an Instagram post. This is a picture that supposedly is an Instagram post. What makes an Instagram post is the fact that it came from Instagram.com. And that's the only way you can make sure that an Instagram post is that it came from Instagram.com. And that username is actually a valid username. That's Instagram.com telling you that is that username. So we're stuck in this place called Instagram.com. And we're also stuck in time because you have this time window up until that Instagram.com actually exists. The moment Instagram.com doesn't exist anymore, your time window to verify that some Instagram post actually was authentic is over, right? Because the authority is dead. So at that stage, you're lost. Now, let's go into Nostr. So what is Nostr? Nostr is signed JSON over WebSockets. End of presentation. So this is it. For the most part, we gave people papers. This also contains this thing and like a bunch of other stuff. But this is Nostr. So this is a bunch of JSON. And let's go over it. So let's start at the second thing, which is the pub key, right? So these are your key pairs. So this is the public key. And this represents the author of the event. We call these JSON things, we call them events. And the second one is the created at. So this is a timestamp where supposedly this event is created. The kind, the third one, the fourth one is that the kind. That's it's a number. It's just a way to specify what type of event it is. Events can be all kinds of things, and this is like a simple number system to reference what it's supposed to be. And then we have like the actual meat of the event, like what's going on. That's separated in two parts. We have tags and we have content. just think of tags as like structured data meant for machines, and the content like stuff that is actually meant for humans. And then we go to the top. We have the ID. So this is the event ID, and that's just basically the name of the event, of the reference number for the event, created by hashing all we've had before. And at the bottom, we have the signature. So we take our private key and we sign the hash. And that way we ensure that actually we are the author that is specified in the public key. And that way the outside world can actually verify that this event, this Nostr event, is authentic. All right, now um, in terms of like the protocol, you can look at the sheet. There's a bunch of things there, but for the most part, this is it. And I kind of want to go into like, is this an invention or is this a discovery? So technically, I'm not going to do the technical argument. It is an invention, um, but I'm kind of arguing here that it's a discovery for the reason that I started out saying like there's a paradigm shift, and we start this paradigm shift because we're beginning with using public-private keys, and from using these public-private keys, there is this logic unfolding, and the only little hurdle that we're going to have to set is that okay, we're going to have to set a standard for a data format. We're going to have to set a standard for the cryptography, and we're going to have some standard for data exchange. And it just so happens to be JSON, SHA-256, and Schnorr, and WebSockets. I guess the point is that it could have been something else. It isn't, right? The point is also that it isn't. The point is that it is JSON, it is SHA-256, it's Schnorr, because otherwise it's not a standard, right? So it could have been something else. It isn't. Deal with it. If you dislike the fact that it's JSON, I'm very sorry. It's not going to change. Just deal with it. No, I mean, the thing is, it's not that important, right? It could have been something else. It's fine. Now, you'd probably think to yourself, if this is the entire protocol, and people want to build like social media out of it, or other types of applications, how do you do well whatever? Like the Nostr protocol is going to respond. It's like, I don't care how you want to do things. You'll figure it out. The protocol as such doesn't specify a whole lot of things. And that's great because it gives you room to figure out those things for yourself. I'm going to help you because we're going to figure out, this thing has existed for a couple of years now. We've figured a bunch of things out. So let's go back to the platform thing, and there are three functions, right? We have the identity in the network, we have hosting, and we have indexing. And with using these public-private keys, we basically covered two already. We covered the first one, which is identity and network. So that's your public-private keys, right? So I can create my own identity. That's my own identity, and then I can just follow these other public keys, and that way I can maintain my own network. So I don't need the accounting of a platform anymore for that. And because, as I explained, these Nostr events are their own self-contained thing. They're not location dependent anymore. We also kind of fix this hosting in terms of that it's not centralized anymore. We can actually just decentralize and distribute this hosting problem because it doesn't matter where stuff is hosted. It can be hosted anywhere. And then the last part in terms of like the indexing, so this is your search and your suggestion algorithms and all this type of stuff, your feed. Now let's go into that. How are we going to fix that? Well, first, we have like a fundamental question, right? How do we find anything, really? Especially if there's nothing specified about it. Well, the saving grace about using these public-private keys and hashing stuff is that we're using with unique identifiers. So we have unique identifiers for the events. We have unique names in terms of using public keys. So because they're unique, you know what you're actually looking for, and you also recognize once you found it, right? Because you can verify the thing. And this is very important because let's say you have nothing to go off. This is at least something you can go off on, is that once you found it, you at least know that you found it. And then we can build on top of that. We can just simply say, well, I can just tell you where you can find my stuff, and I can sign that message, and that way you can know that it's authentic, and that way you're not being fooled. The fact that things are signed, it's like it gives you a way to differentiate between signal and noise, right? So now I can just tell you where I can find my stuff, or where you can find my stuff, And I can put that, for example, in like a public repository where everybody else is like a convention that everybody just puts this type of information where you can find their stuff onto this public repository. And now we've probably like covered 90% of the problem of like where can you find my stuff. Um, so this is the basic thing. We don't have to create all these difficult or complex things to try to get like the 99th percentile of the problem of finding things. No, this very simple basic thing will probably cover like the most of it, and then maybe for that last part you'll either do more effort or we'll make more complex things. We'll see later. So, as a small aside, well, we're talking about Nostr, and Nostr is like these JSON events. It's a bunch of text, right? But there are also other things out there in the world, like pictures and videos and files and programs and whatever. We're kind of like in hindsight, basically figured that we can do the same for that. You just hash the thing. It now has a unique identifier. Therefore, it doesn't matter where it's hosted anymore, and we'll just use the same logic of giving you hints as to where you can find it. And the moment the link breaks, we'll just rehost it somewhere else, and now we'll update the hint list, and hopefully the link is healed again. So we're not just it's not just about the location restriction. That's something I want to mention. It's also that this time dimension, right? Like I said, from Instagram.com, you're stuck on Instagram.com, but also you have this time frame. The moment Instagram.com is down, your moment of verifying things, your possibility of verifying things is over. And with using this schema, that's not the case. Things can go down, things can be unhosted, and then suddenly pop up again, and you can just verify them all the same. You can put them in a clay tablet, you can put it in the ground, people in 1,000 years can dig it out of the ground. They just have to type in the numbers, run the math, and if the cryptographic computation gives true, it's all fine, right? So we're not restricted by this time element anymore as well. All right, so I want you to imagine that there is this anywhere, like these Nostr events can be hosted anywhere, and there's a whole bunch of them, so it's utter chaos. So we're gonna have like signed structured data in like this chaotic construction. It's just stuff out there. It's this mist of signed JSON events. How we're gonna make sense out of this? And I guess the basic method of doing that, where in like an abstract, where it boils down to, is by applying these lenses. And these lenses, like the simplest lens is basically saying, I have a list of followers, or a list of people that I follow. It says npub, which stands for Nostr public key, just to make it clear. So I have a list of people that I follow, and I use this lens to look through, to look at this mist of signed JSON. And excuse me for using the old fallacy of that vision is a projection of the eye. This is the case in my metaphor. And once you apply that, you can now filter out a whole bunch of stuff, and you only get the things that you actually were looking for. And you can what this stuff represents, right? What these Nostr events, what this signed JSON, what this represents, can be all kinds of things. So they can be tweets, they can be blog posts, they can be pictures, they can be recipes, they can be applications, they can be climbing routes. It doesn't matter. It can be all kinds of things. And the beauty is that you can leverage your network, these lenses, to figure out for all these different domains, right? So if I'm very vested, I've had like a very good network of all kinds of chefs, right? So I have a good constructed lens of I'm following all these chefs, so I have a good way of gauging the chaos that is recipes. I can subsequently also use these people for when I'm doing climbing routes. Now, they're probably not as useful in the climbing route situation, but they're still there, right? And that's basically the beauty, that we're now also starting to leverage our networks for other applications. And that's something that I'm going to accentuate later on as well. Now, we kind of want to navigate, right? We used to surf the web. I don't know how many people surf the web these days, but you kind of want to be able to do that. So there are basically two modes of doing this. One is npub centric, and the other is relay centric. And the thing is, I kind of already explained the first one, and because the first one was never specified anywhere, the creator of the protocol just assumed that this is logic. This is the logical way of doing things, right? Obviously, hopefully it's obvious that as I explained them to you earlier. But apparently it wasn't that obvious, so it had to be like made explicit. So now it has a name, and the name is Outbox model. And it's very simple. It's just that you declare where you host your stuff, right? So in Nostr, we have these servers, we call them relays. And basically on the left is the person who's publishing. On the right, there's the person who's following the Pamela. And in between are the relays. And there's this whole dynamic going on with this relay hosting things and then subsequently banning them. And the whole thing of not being able to stock in a certain location, like not being location dependent, is that you can switch relays all the time. So the moment you get banned somewhere, someplace, you can move to another place. You just update your list of where you hosted your stuff, and then the people following you can follow along with that list and keep track of you. Right? They basically don't even notice if you automate this stuff. They basically don't even notice that there are relays banning you in this entire process. And the other way of going through things is using relay feeds, right? So now these servers, they can say, okay, I'm just only going to host particular kinds of data, right? I'm only going to host recipes. I'm only going to host pictures. I'm only going to host tweets. I'm only going to host whatever type of thing. And the point is that they can use any metrics. They can also say, I'm only going to host stuff by these people. So, for example, only accredited academics, right? Only accredited academics can post to my server, or they can only post stuff about astronomy, or any combination of whatever you can imagine. They can create their own environment, basically like a website with a forum, and that becomes a method for you as a user to filter out things and get a feed. Now, the beauty is that basically Nostr is a protocol. It's like the whole point of it is censorship resistance, but it's pro-censorship. And what I mean by that is that because the user is themselves are censorship resistant, that allows relays like these hosting servers to censor and moderate in whatever way they please, right? You're not in each other's way anymore because you're not always stuck on this central platform where you have to battle it out in order to what the policy is going to be, right? Are we going to do fact checking? Are we not going to do fact checking? All this type of stuff. It doesn't matter anymore. People can just pick their own. These relays can pick their own policy because the users, on the other hand, are like flexible in how they move around, right? So now we're going to have what we get as a result is freedom of association. Because the whole point is that when, let's say I'm having an astronomy relay, and I'm looking at the astronomy relay and I see a very interesting astronomer there, I start to follow that astronomer. The moment I follow that astronomer, it's not that I'm relying on that relay anymore. I'm not relying on this little astronomy platform anymore. I now have this direct relationship with that astronomer. I have his lists where he posts his stuff, right? So the moment he gets banned from from the astronomy forum because he has controversial opinions, I didn't lose sight of this astronomer. So this puts a lot of away of a lot of friction that we're currently involved with. Now, there are a whole bunch of other challenges when you're trying to build a web and you're trying to build social media and you're trying to do all kinds of other things. And I guess basically the main point is that there are different places where you can tackle things. So you can tackle them client side, right? You can tweak things with the lenses. You can create filters locally. You can fix things on the relay side, or a combination of the two. And the thing is, with the client side, it doesn't necessarily have to be like the client the user is using. You can also outsource it, and that's what we call DVM. It's data vending machines, which is basically a client somewhere else that you can ask to do a job, right? So we can imagine these lenses. You can do. Let's imagine constructing a very complicated lens where we say, okay, this is the people. These are the list of people that I follow. Let's do a cluster analysis on those people in terms of how they interact with each other, and then we focus on that cluster, and then we do an association for everybody who's associated with the cluster, and then that's how we built this complicated lens, right, into projecting all these Nostr relays. And let's say that's far too complicated to do on my phone, so this is just something that I'm outsourcing to the DVM. Or I can just outsource the entire thing and just ask some other clients that give me a list of events that I can look at. So we have a lot of room in how we want to tackle things. Now, Let's talk about clients because we haven't talked about clients just yet. And let's do a stupid statement where I'm going to say that Nostr is more like cloud computing than cloud computing ever was. So what do I mean by this? Let's go over what the basic procedure of any Nostr client actually is. If I can get the cut off. Let's assume we bought a new phone, right? Fresh out of the box. And we take this phone and we download a new client or app on this phone, right? So new phone, new app. What we do is we basically insert our private key and we're returning the key, right? We're booting up the application and the application starts working. What does the application do? It receives these keys. It sees, okay, this is the public key that is associated with this key pair. Let me start looking for what can I find about this public key. So it starts to find like profile data. So this is the profile picture, and this is the bio, and this is the people that he follows. And oh, apparently he also has like there's also like an event with general app settings where it states that he prefers dark mode. So let's put myself into dark mode automatically. Um, there's all these things that he starts to gather all these things and basically to initialize himself or initialize itself into the context of the key pair that it just received. And then it can start to run its operations. So maybe it's a cooking app, right, or a recipe app. It starts to gather the chefs that you follow, and then subsequently starts to churn out a feed of recipes that you like, or any other application. And I guess we can. Do we have time? Yeah, we have time. We can go over like another example. One that I'm very much like because most of the Nostr apps that you're going to use right now are probably like Twitter type apps like microblogging. But there's also an app store, right? So you have like this Nostr app store where you put in your keys, and then let's imagine you have like Nostr Steam. Doesn't exist yet, but let's imagine you have like Nostr Steam. You have your existing network, right? You have your friends, and just based on that, the client is immediately able to just look at like, okay, what type of games am I going to recommend to this person to download or play based off what his network is playing. Um, so the point of it is that you're because there's in the example that I gave, like it's a new phone, it's a new app, right? You're not restricted. We were not restricted to time. We were not restricted to location in terms of where it's hosted, but we're also not restricted to a machine, or we're also not restricted to a particular client. Like switching to a different client is frictionless, and that's the whole point of Nostr. So what's the result of this? Like a result of proper Nostering is that we can actually leverage platforms for what they're good for, right? Because the platforms were really good in the indexing part and gathering specific types of information. And but we cannot get cut off from our following or the people that I follow. And I can switch between apps without friction, right? It's not that I'm stuck with like the Twitter app. I can just use other apps. And I can leverage my network throughout different applications. And that's something I'm going to go into in just a bit. And as a result is of basically what we've done, what we set out was to see if we can fix this problem where we have both network effect and because currently we have network effect in these platforms, but we run censorship risk. So can we actually solve this? Well, the point of my story here is that we actually solved this, that we maintained network effect and that we've gained censorship resistance, right? So we've solved our problem. So how we're going to actually win? Because these incumbent systems, they still have the network effect, right? So my point here is that you're not going to win against X, and this is why I hate the fact that Twitter's called X now, because I actually mean it as a variable, not as the. Um, so you're not going to win against Instagram on the merit of being a better Instagram, or you're not going to win against Booking.com on being a better Booking.com, etc. Right? Don't compete head on. The way we're actually winning is by the fact that we're capturing network, because they got the network effects on the vertical, right? They chose a specific domain, be it pictures or microblogging or whatever, or cars, like taxi driving. They captured their vertical. What we are able to do is like capture the entire horizon, because what we're able to do is maintain this network effect over all these different applications. So we're going to conquer the margin, and from the margin, we're going to take the center. So we're going to have a marginal Twitter app, and we're going to have a marginal Instagram, and we're going to have a marginal recipe app, and we're going to have a marginal booking, and we're going to have all these marginal shitty apps that barely anyone uses. But the point is that the the added value of the network effect of this interoperability between all these apps and the network that I can maintain through all these apps and through all these different applications is that the added value is going to be higher than the individual network effects that I'm going to experience in these large centers. And that's ultimately the tipping point that we can achieve, is that because we've conquered all these edges, at some point it just flips, where now that network effect of all these marginal applications is higher than the network effect individually captured into these silos. Now, I have a small developer addendum here, and that's because I'm gonna try not to shit on the other projects just all too much. But basically, the point of Nostr is that like simplicity lowers the barrier of entry, right? Um, the the protocol that we handed out, this piece of paper, the NIPO1 thing, is very simple, and it's so simple it's like minimal viable for nothing, right? You cannot actually build a serious application with just that standard. You need other standards on top of it, and this is what we call NIPS, Nostr implementation possibilities. But the point is that basically the NIPO1 thing is that it's minimal viable for its own development. It's all we actually need, and then for whatever application or that we're trying to develop for, we can introduce other standards, build things on top of it. That's fine, but you can start out and think and say is like, okay, well, we want to make social media, so we have to take moderation into account, and these cryptographic key pairs are very difficult, so we need like an identity server, and you create this very complex stack. And if I'm here saying, well, I just want to build a weather app, I don't care about all that stuff. I just want to build a weather app. So if you're going to put all that stuff at the basis, now everybody that wants to build a simple weather app or a simple agenda app now has to deal with all that crap as well, right? So this is basically the point. It's like, sure, if you want to create all these more complicated applications, you need all the complicated stuff. That's fine, but it doesn't have to be at the base protocol. That's basically the point. Yes, I guess I'm gonna leave it at that, and I hope I'm gonna be able to ask or answer a lot of questions. Thank you. Okay, so I'll just repeat the question. How do I deal with compromised credentials? Cry. I bought a forest for this purpose. That's right. I can cry, cry, cry alone. Don't be bothered. I'll just point in the air too. So your question is about like your data being hosted, and if you're so the example that you gave is I've created my profile. If like it existed for 10 years, I've done a whole bunch of stuff in that 10 years. It only existed on this one particular relay. Now that relay shuts down, is my stuff gone? Yes. We're not in the business of selling magic. We're not actually in this business of selling anything. There's nothing to sell. It's an open protocol. But yes, there's no magic. The point is then you're flexible, so you can actually just you can host it redundantly on another relay. You can save a copy. So let's take this. So you use a relay, right, out in the open, a more public relay, but you can save all these files if you save them locally on your computer. And now that relay is gone, you can just upload everything on another relay, because you're like I said, you're not time constricted anymore. So if it's like, if there's 10 days in between, if there's 1,000 years in between, it doesn't matter. But yeah, it's not, we're not in the business of selling magic. Data has to be hosted. It has to be on a drive somewhere that is connected to the internet.
Hi, so I've been given a mic, so I'm going to
Perfect.
ask.
Yes, that's
So
better.
I hope this isn't repeating the first question, but so because the identity is your public key, the public key is your identity, then presumably there's no mechanism for key rotation, and therefore if you lose your key or it's compromised, that's it. You just have to scrap it and start all over from scratch. Is that right? And if isn't there any kind of key rotation mechanism that you could kind of build in? Wouldn't that be nice?
So the thing, basically what you're asking for is not, you're not solving the problem. You're just moving the problem one step forward. The thing is that the answer is you can do whatever. You can create a key rotation standard, and you can implement that and you can start using it. It's just going to be, you're adding complexity that you cannot be assured that the rest of the network's actually going to. The only thing that you can assure that everybody else can follow is this do or die key. Right now, I'm not going to leave you dead in the water right there completely. So one of the things that I cut out of the presentation, well, I'll just address now before we get like 10 other key management questions, is the first thing is that um, the use of public-private keys for the masses didn't really happen for a very long time. It's been used for a very long time. We have PGP keys, and the only people using PGP keys are like the crazy people sitting in this room, right? Um, Nobody's mom ever used PGP keys. Now, the thing is that with the advent of Bitcoin, basically, this forced or introduced basically a larger industry of managing these public-private keys, where now millions of people actually do manage these public-private keys for their money, right? There's serious value going on, and apparently it's good enough for them to manage money. So now our question here is it also good enough for our identity? And if it's just shit posting online, it's fine, right? If it's very, very super duper serious and we're the president of some country, maybe we can consider some key rotation scheme, right? So, but there's also like a spectrum of application going on here. Also coming on with that fact is that because because we have an industry that is trying to service key management for the masses, they're also trying to develop best practices and hardware wallets, all this type of stuff, and also actual cryptographic research. So because we're using cryptography at the core, we can actually start using these cryptographic magic schemes of threshold signatures and all this type of stuff, and we actually have it implemented. So if you go to start.njump.me, you have a nice onboarding sequence, and in that onboarding sequence, it gives you the option to split up your key basically, and you get a link, and now you can use this link instead of using your private key directly. I'm not going to go into explaining that completely, but these are like mitigating factors. The last one is that there's a generational component to this, right? If you've grown up with this stuff, it's a lot easier than if you're like an old fart already and have to change everything you do or change the way you think and start into managing these keys. So it's also a matter of time until a lot more people are more comfortable in dealing with this stuff. All right, next question.
Yeah, no, I just want to say, because I never heard of your thing, or protocol.
That's
I
great.
would say it's really great because it's a big fight, no, for the freedom and to put down this big tech, like those that hold the Twitter, Facebook, and things. So it should be free and it should be for everyone. So I'm just wanting to say that, and I will try to use it and to build some apps using your thing. So it looks really good.
Yeah, it's just JSON. You'll figure it out.
Yeah. Yes, very. No, but it's really, really cool, and it smells like Bitcoin thing, like chain things, like you spread all around the web things, but it's really good. I really think that there's no one place where you keep and sell stuff. It's just everywhere. So
Correct.
very cool. Yeah. Thank you.
Yeah, hello. You said that you don't have to trust relays, and so whoever gives you the data, you only check the signature and you rely on that.
Yeah.
Is there something that prevents me from, as a relay, providing fake data to make people lose time until they verify the signature? If there is a huge amount of data, and if you have no way to discriminate relays from one another.
Well, you do have ways of discriminating relays of one and another, because they're just different servers, right? So you make an explicit WebSocket connection to one particular relay, and if you're getting consistently get junk, I guess you just stop using that relay.
As a client,
Yeah.
you can specifically include or exclude some relays.
Yeah. Yes, very much so. Yeah. To some extent, you kind of have to. To some extent, you depending on what kind of application you use. So it's, for instance, it's very similar to if you think of these relay feeds. Like if you think it from the perspective of relay feeds and not the NPub model of just following people and picking whatever relay that they use, but specifically following a relay, it becomes very much like RSS, right? But instead, it's very much like RSS, but now all the stuff is signed.
Thanks for your talk. Yeah, thank you. Is there an economic incentive for running a relay?
It depends on what you're doing. So there can be an economic incentive by simply having a paywall for your, like asking payment for your relay. I use a paid relay because the incentive for me is that it gives me a certain amount of trust that they're going to be there next year. Also, it can also be people run servers or businesses run servers and they're not directly being paid for running those servers. It's just part of their business, right? And they actually get paid for something else, but they need the fact that they need a running a server. Also, it's like it depends on what you're doing. Running running a web server basically is not necessarily how much of a cost thing. Like unless you're YouTube, right? If you're YouTube, it's like different. But YouTube is like the hardest problem out there, basically. But there are a lot of simpler things. Maybe as a weather app, I don't know how heavy it's going to be as a weather app to run that service. But maybe you just sell your weather subscriptions and you pay for the relay just based on the fact that you're running a business. So I have no specific answer to that question. It's 2025. The internet has existed for a long time now, and servers are actually running. And in a lot of cases, nobody's directly paying for much of anything. So I don't know. Hopefully, we'll figure it out.
Is there a versioning story, such as if the encryption needs to be updated, the algorithms need to be updated, or anything like that?
My answer is basically just like the same thing. If your keys are compromised, is cry. If Schnorr is compromised, I guess we'll just have to cry. Like in implicit, like I'd say in terms of like, is it implemented in the protocol? I don't think so. No, it's just that as users, if the crypto is broken, we're gonna have to use a different crypto. And hopefully, we can settle on a new crypto at that stage. So what you're saying is that you could just run a version number on things. I guess the thing is you're basically running. I guess you can it could have been specified in the kind already, right? You can just use a different kind number. If you're saying, okay, we're using different events on a different standard, We'll just give it another kind. That's another way of tackling the problem as well. Any other questions?
Hi, you over here.
Yeah.
To paraphrase, you said that because it was too complicated for normies to set up a website, perhaps Meridian, they were driven into techno-feudalism. How
Correct.
does this solve for that? How does it make things less complicated?
No, the thing is that you can shop for your landlord. I guess that's the point, right? The thing with the techno-feudalism is that and this is the point about being stuck to a location, is that they own the territory. The thing with the internet is that in the internet we're not actually bound by space, but it's only because we're going to these specific platforms we're now are bound by space, namely the space of their server. And the whole thing is that you can always just put a net server next to it, and now we've created a whole bunch of new space, right? So the way you solve the problem that you're positing here is that the techno-feudalism is that we're not space constricted anymore. You can just put another server next to it, and now we've created more land.
But in a sense, you could always do that. It was just complex to set up many mirrors, to have proxies and relays and all sorts of things. The whole point is that the reason people didn't do that was they were then driven to the central landlord and said, forget it, I can't
Yes,
do
but
it.
the problem
How does this solve for that simplicity? How is my mother going to use this?
Yes. So that was the whole central thesis of the presentation, is that you're now stuck in this vertical, and with Nostr, you solve for it, is that we've now got network effect over all these servers. So the network effect is not captured in the server anymore. So I get what you're saying. It's like, okay, it's you get like let's assume that it doesn't relieve any complexity. I mean, running a relay can be as simple as just running a Raspberry Pi, but let's assume that it's not, and it's still going to be 5 servers. The whole point of the protocol is that your network, your identity in your network is not stuck on one of each of these 5 servers or 6 servers. I don't have 6 separate accounts at Facebook, Instagram, and these places. I just have one profile that functions over all these 6 places. So that's how it solves for it. Like, let's assume that that it's still too complex and it's only going to be 6 servers, then it's still better than what we have now. And on top of that, it's probably a lot easier to do self-host, at least for your own stuff.
Hi. Let's say this protocol blows up to the size of Facebook, Instagram, Twitter, etc. How would this decentralized relay system hold up performance-wise? Because the traffic can be really unequal or like weirdly spaced globally. Like how does it hold up?
So I guess in terms of I guess my answer is going to be like a spectrum, and there's going to be probably is going to be a power law, and it's basically a tie-in to the answer I just gave to the other question. It's fine if there is like a large chunky server for a particular use case, in order to do especially this. It's also, I have the 2 modes, right? I'm on time. I have the relay centric thing and the MPOP centric thing. So when we think about when we think about a use case from the MPOP, oh, I'm not sharing, whatever. When we think about the use case from the MPOP centric stuff, where we're just following people, and I'm just trying to figure out where I can find stuff that they're posting, their stuff is probably distributed over a whole bunch of relays, right? So in this case, it's not that there's outsized pressure from a whole bunch of people on one particular relay, because everybody is using the same relay. It's a whole bunch of people are using a whole bunch of different relays. So we got a distribution of load in that case. It's what more happens or the problem more arises on the relay-centric mode of operating, where we have like a very popular relay because they're like, let's say the astronomy, we have a very, very, very popular astronomy relay that the entire world, we have billions of users on the astronomy relay. then it's just the same way of managing the infrastructure of web hosting than it is today. Correct. Yes. So like I mentioned, is that we are able to leverage platforms because we can still use these platforms. The problem arises that the moment we have a platform that is very popular, has a lot of users, we run this censorship risk, right? But we actually solve for this censorship because, okay, you can be kicked off of this big platform, but you don't lose all of your followers because you don't follow the people you follow through the relay. You follow the people you follow for the fact that you know where to find their stuff. Does that make sense? Okay, so basically your question is like what prevents like an application or let's say a client, what prevents from a client that you're using on your phone to create a special relation to a relay and basically create proprietary relationship between a client and a relay when it becomes very popular, and basically start to undermine the standard of the protocol because it now becomes its own dominant standard of the protocol. The unfortunate answer is nothing except for our own vigilance. And hopefully we can hopefully we can bootstrap this thing fast enough and create enough network effect among all these marginal applications in a way that it always outsizes this newcomer that wants to get big on its own, right? Because basically he starts to compete in exactly the same way that we are competing with the central platforms right now. So the moment we win against the central platforms, it's very unlikely that we're going to have to suffer this type of attack again.
Please don't speak without a microphone. It's a bit disrespectful. Thank you.
Do we have time for more questions?
Last one.
Okay.
So you started out by the problem with the verification, and if one platform goes down, then you can't verify anymore. But I don't really see. So the nice thing is that you tie everything in the message, so the message is standing on itself, but the verification does not. You do need to have somewhere where the public key is tied to the profile, and there is an authority. You can ensure, like, okay, someone did not create a different duplicate profile with just a new signature, and then it seems to be with my face on it or yours. So how do you then still solve that problem that as the relays are multiple, but then you still are tied to a single authority that needs to exist, otherwise you can't verify anymore?
No, so it's I understand your question. The thing is that you don't need a central authority to do this. The basic way to approach this is that we're face to face now. We can exchange keys, and as long as those keys are not compromised, right? That's always the basic assumption of this stuff. But the moment those keys are not compromised, I don't need an authority to know that you are you, right? And that if you say that you're using these keys, that I can identify you based on that basis. And then if we have a bunch of people in common, we now have like a web of trust type of thing where I maybe even trust your extended network as well. And when we have a bunch of extended networks, we're very quickly start to gather like a large part of the population and maybe even everybody. So that's the web of trust is basically the base of the answer.
Yeah, thank you.
I'm out of time, so thank you a lot for all the questions, and see you on Nostr.
There's always the hallway track, so